Welcome to the Embedded Frontier podcast, where we explore modern embedded systems development techniques so that you and your team can develop faster, smarter firmware. I'm your host, Jacob Beningo, founder of Beningo Embedded Group, the Embedded Software Academy, and co-founder of the Embedded Online Conference. In today's episode, we are going to talk about the topic that you can't get away from no matter where you go. And that, of course, is artificial intelligence. Now, for us today, artificial intelligence, we are going to look at it from a slightly different perspective. Over the course of the last half dozen or so episodes, maybe a little bit more, we've been talking about how embedded development teams can modernize the way that they develop embedded systems. This is the embedded frontier. We are trying to adopt new technologies, new techniques that change the way that we develop software. Things that help us go faster, improve the quality of our system, and hopefully minimize the number of bugs that we have. And so ultimately what we're trying to do is develop products on time, on budget, make sure that the complexity is maintained and that our customers have a good experience and don't have issues with the products that we're developing. Now, we've been talking in this series about modernizing your build system, updating your embedded software architecture, adopting DevOps, test-driven development, how simulation can help you run your code, do functional simulation on your actual host machine before you ever get it to target. Well, today, AI is that sixth step of how you can modernize embedded systems. And I say steps, but really, I think any of these can be done in different orders based on the team and where you are currently at and what problems you have and what solutions and problem space you're trying to solve. Now, what I have found personally is that a lot of teams will say, oh no, artificial intelligence is not for us. We can't use AI to help us go any faster, to improve our bug rates, to develop our software. It's a no-no. We're embedded system developers. We're special. You can do that for vibe coding or mobile apps, but AI doesn't apply to us. Now, one of the first things I want to tell you is that idea or that assertion is actually 100% wrong. Every team can be leveraging AI, even if it's in very subtle ways. What I believe every team needs to be doing is identifying how you can use AI to solve the problems that you are facing as a team, as individual developers, even as a company. Now, what you're going to find is that teams who are ignoring AI today, those are going to be the teams that are going to be left behind. Okay? AI has the opportunity to actually help us to develop better embedded systems. I teach a seminar called Faster, Smarter Firmware. It's not a course about AI. It's about how we use these techniques that we've been talking about, these different steps, and how we actually, as a team, develop more robust, reliable systems, how we do that faster, how we raise the bar on quality and produce a really good product for our customers. Now, AI, I think, is really interesting because my first impressions of it, just like every other embedded developer, was no, we can't use this in embedded systems. But what I've been finding is that AI actually has a lot of potential applications for developing embedded systems. Many of you probably jump straight ahead to, generating code, right? Where you think about essentially agentic workflows, where what happens is you say, go build me a widget, and AI runs off on its own and churns for, a couple of hours and comes back with something that works, okay? Now, don't get me wrong, I've experimented with that type of development as well, right? But what I have found is that if you just try to use agentic workflows, it's not going to work out for an embedded system. That's not the right approach for us as developers and as teams. What you want to do is use AI almost in an agile-like manner. You want to use it iteratively. You want to find little small problem spaces that you can apply it to, and then iterate over the use of AI over the course of many sprints and over the course of months and different projects, potentially even over years. And over that time period, what will happen is that you'll find better and better ways to apply AI to the way that you develop embedded systems. Now, let me give you an example, okay? Early on, when I started working with artificial intelligence, I would just go and let it essentially vibe code for me. Okay. Maybe the couple first examples I did is I played with, creating push buttons or trying to see if it would write drivers for me and, do code reviews. And sure, you could get some results by doing some of those types of techniques. But if I just let the agent go and do whatever it wanted to, it really didn't work out super well. what I ended up finding was that you want to create a tool set of specialized AI tools that have knowledge in specific embedded systems domain areas and leverage then those tools when you need them. Okay. Now, certainly you could, have some master agent that orchestrates all of them together to try to build something for you. And it's kind of fun. I actually did an AI push button as part of a course I did a little while ago. And, it generated all the code and did some really cool stuff. But before I kind of get into those types of details, what I want to kind of give you an idea of and give you some examples of how this actually works. Okay. So let's use the push button as an example. Maybe you have a debouncing algorithm that you have to create. Okay. That's something that all of us have to do at some point, right? Most of us have a button that has to be pressed on our systems. Well, you could just tell AI to go ahead and just, make the whole thing for you. And, you just kind of look at it and say, okay, well, cool, whatever it produces, right? Well, instead, what my recommended process would actually be is that we break this up into smaller and smaller parts. Okay. So for example, I start out by, I've created a skill essentially for AI or for agents that allow me to say, hey, I want to work through my user stories and the requirements for my system. Okay. And so what it does is I could supply requirements that I've already put out together, or I could provide a description of what the product is. And then it will essentially prompt me to get some more details, and it will generate a basic set of user stories for the product. It'll try to poke holes in it and give me a full list that I can then go through and I can review and say, okay, does this make sense for this product? Would a user use this product in this way? Now, I know many of you start with fully required systems, right? You start a new product, and I know you all have all of your requirements in place, right? Right from the very first day of your project, right? Or not. It actually turns out that probably fewer than 5% of us actually have all of our requirements, and many of you are probably laughing, going, "What requirements?" Right? Well, you can leverage AI in that way to give a product description and let it kind of come up with some use cases, and then you can go to your product owners and say, "Hey, are these accurate user stories of how the system actually behaves?" If the answer, they might look at it and say, yes, this is good. This is good. Oh no, we don't need this. Or, oh, but what about this, right? So you can use AI to help you brainstorm around what the product should actually do. Now, again, you might say, well, that's technically not being used for embedded systems development. That's for requirement solicitation and management. But let's be honest. If you look at the software development lifecycle, requirement solicitation is actually a very critical piece of that lifecycle. And it's required that we have good requirements in order to build a good system. Okay, so we can at least leverage artificial intelligence for requirements, getting user stories. We can leverage it actually to build out additional capabilities that we would use maybe even to generate code. So for example, if you have a coding style that you use or a coding style guide, you can break that guide up using RAG and build agents that have access to that database that can then review your code as you write it or before you commit it into a database to make sure that you're adhering to your company coding style guidelines. Sure, we can use static code analyzers for that. I'd highly encourage that you actually do that as well. But what you can do is create skills that actually have all of that built into it, or generate MCP servers that have tools that can go through and actively statically analyze your code and verify that you're following the best practices that you have come up with as a team or as a developer before you commit your code. You can also make it so that AI agents run in the cloud and perform those exact same activities. And so the way that I have been using artificial intelligence is that as I develop embedded systems, I stop and I look at what I do on a daily basis. And as I work on stuff, I say, hey, I've done this 3 times this week or in the last 2 weeks. Does it make sense for me to either create a prompt to allow AI to try to start helping me automate some of this? Does it make sense for me to use artificial intelligence to create a tool that I can use? I'll tell you right now, I have about 30 different tools that I've created over the course of the last 6 months that help me develop embedded systems and debug embedded systems. I have tools that will interact with, my Saley logic oscilloscope that you can see behind me if you're watching the video, or that can interact on a serial port and parse I2C data, or parse debugging information and ... It just goes on and on. Anytime I find I'm doing something over and over again, I say, hey, maybe I should build an agent or a skill or create an MCP server that has these capabilities. I actually created an MCP server that helps streamline my Mizra C process. I have a certain process that I follow when I'm writing code that I'm using to validate that I am adhering to the Mizra C standards. And, I can have a RAG database that's, has pieces of the standard or something, but at the same time, I can define, running a static code analyzer. I can ask a bot to perform the reviews that maybe are harder to review, and so on and so forth. So look at what it is that you're doing on a daily basis and kind of say, hey, where could I automate this a little bit more? Now, I'm not talking huge automations, agentic type of automation. I'm talking about little helping things here and there. Something that can review a function. Something that can provide a recommendation based on, having read a data sheet. Maybe an agent that goes out and performs some type of research for you while you're actually debugging a system. There's all kinds of different applications there. And I think the teams and the developers that really play with these tools, that don't ignore them, these are going to be the ones that are long term. They're the ones that are going to be the most successful in, I'll say, the embedded systems industry. Okay, you shouldn't be ignoring these tools. This is the embedded frontier. Adopt the new technologies that are coming out. Figure out where they work, where they don't work, where you can actually apply them for what you're working on. Okay, now, kind of mentioning those types of things, when I started playing with that AI push button, what I ended up finding was that if I followed a very agile-like process, and kind of defined and create little tools and skills and MCP servers that would help, I could get to a point where I could say, hey, auto-generate this code module for me. And AI could actually write the code in my style because I had trained it using my own, my own examples of code that I had written, experiments I had done, my own coding styles. And in very small little implementations like that, like a single module, you can get to a point where, AI can get you 80, 90% of the way there. But, if you're starting to get too excited about some of this, be careful, because AI doesn't always do what you expect it to. And my favorite example of this is when I was putting together a universal AI push button module using AI to, as part of my experiments, I had put together an agent that I had trained to do test-driven development. It knew, the red, green refactor cycle. It knew to make a list of tests, make one fail, write only the production code, and then after that, run the test again to make sure that it passed, and then kind of move on, right? And so I was like, oh man, this is fantastic. I have this thing ready to go. This is going to generate really great AI push button code. And I told it to go. And 4 seconds later, it comes back to me and says, all right, everything is good to go. Everything works perfectly. And I was like, what do you mean everything works perfectly? It's been 4 seconds. Like, I know there's a lot of compute power in the tools and on servers today, but what I was asking it to do seemed like it should have taken a little bit more than 4 seconds. At a minimum, the fact that it was going out and having to compile code on my machine, going through that TDD process, it should have taken longer. And so when I queried the AI about it, it said, oh, no, I didn't follow that process. I just wrote all the tests and then I wrote all the code. And I said, well, what about the way we developed our agent? Why aren't you following the red, green refactor cycle? And the AI responded to me, oh, well, that would take too long. So there you have it right there. Even AI, even if you give it the right tools, tell it what you want it to do, there's no guarantees that it's actually going to follow what you're trying to program it to do. Okay? And so maybe right there that makes you say, well, no, I don't ever want to use these tools. But here's what's interesting, what happened after that. After that, I said, no, let's do this the right way. I don't care if it takes longer. We should always be making sure that we're following this process. If it takes more cycles, more tokens, more time, I don't care. Do it the right way. After that, it went through and it churned for about 45 minutes, of which you can imagine, 45 minutes to create a simple universal push button debouncer. Yep, that's how long it took. But at the end of the day, it had actually developed something along the lines of like 98 different unit tests. It followed the full TDD process. We ended up with over 4,500 assertions, which were checks that the code was actually doing what it was supposed to in the test harness. And then I actually had a universal push button module that, after looking at it, I don't want to say it looked exactly like I wrote it, but it looked fairly reasonable. Okay. And then under actual testing on hardware, it worked like a push button module. Okay. Now, again, this is a simple example, But think about where this technology is going to go over the next 1 year, over the next 2, over the next 5. Okay. Right now, we're kind of in the wild west of artificial intelligence and applying it to how we build systems. Nobody has the answers. Everyone's just experimenting and trying to see what works. Even within teams that I talk to, there'll be 5 different developers working with artificial intelligence. They'll all have completely different workflows and things that they're doing in order to get the job done. Okay, so we're almost in this point where you can leverage AI in your own personal customizations to help you get your work done faster and honestly smarter, right? We're doing this in a smarter way by allowing AI to help us maybe even develop the tools or at least help us develop software that honestly can be a lot more robust. And let's be honest, as developers, we have so much stuff that we have to do anyways. The complexity of systems today is just growing exponentially. The number of features that customers want. And let's be honest, we want it to be safe. With complexity, it starts to decrease the quality and the safety because there's so much in our problem space that we have to be keeping track of. And I don't know about you, but my mind only can keep track of so many things at one time. For those of you who have heard of cyclomatic complexity, we set a value of 10 for a reason. And it's because our minds can only really keep track of between 8 and about 12 branches or pieces of information at any given point in time. Okay? So once your a function becomes more complex than 10 branches, it becomes hard for us as humans to keep track of all of that simultaneously. Okay? And so when you look at systems that have Wi-Fi connectivity, we have to have security involved. We have to have real-time performance. We have to have a whole slew of sensor fusion. And now we've got AI and we've got the list just goes on and on and on, right? And so, again, AI can be a great assistant, and at a minimum, use it to create the tools you wish you always had to help you develop embedded systems, okay? But I'm kind of teasing you a little bit on what some of this does today. Keep an eye out on my Embedded Bytes newsletter and on my YouTube channel, because I will be talking a lot more about artificial intelligence in the coming weeks and months. I have been using it actively on a daily basis in order to explore how we can develop better embedded systems faster using these tools and different techniques, okay? Now, with that said, you might be wondering, well, what tools should I be looking at if I am interested in trying to apply artificial intelligence to the development of embedded systems? Now, there's many different tools out there. I've played with probably a dozen of them, to be completely honest. My personal favorite is Claude Code. I have found it to be the most capable of all the different tools that I've played with. But that being said, it really depends on what you're doing. I keep an active subscription. I think I have like 5 or 6 different tools that I use. For example, Claude Code is, like I said, it's my go-to. I also use Codex from OpenAI and ChatGPT. I use Perplexity for a lot of research capabilities. I use Gemini. Anti-gravity is actually pretty interesting, although I don't find that it works as well for what I do as Claude Code is. Okay, but there's other tools like Cursor. There's 8n8 is a cool visual tool if you're trying to do process type stuff, and the list just goes on and on. There's so many of these out there. I've probably forgotten some major one, but ultimately, what I recommend you do is try some of these tools out. Get the low tier plan of the free one and just see how it works. And then again, try to identify the things that you do on a daily basis where you could use some automation. All right. Perhaps I'm a little bit different because I apply this towards embedded software development. I also look at how I can apply it to, as a solo consultant, how I apply it to my own processes. And kind of outside of the embedded system space, I apply it to kind of help prioritize my email. With this blog that I'm recording right now that you're watching, after I record it, it used to take me an entire day to go through and process the video, the audio, generate the show notes, upload it to YouTube, upload it to the aggregator that puts it on Apple and everywhere else, and then to actually go out and post a blog to my website and all this stuff. I mean, there's a lot that goes into a single episode of a podcast. And I actually used AI to develop a workflow and scripts that allow me to do I basically record this, and then after this, I run a script that was generated by AI that uses AI as well. And in 30 minutes, I have a completely done podcast that gets uploaded. And the cool thing about that is that allows me hopefully to do more podcasts like this, to do more experiments, to share different techniques with you, and so on and so forth. So it's pretty exciting to see just the amount of time that it has saved me from a business perspective, but also as we start to apply this towards developing embedded systems, I've actually seen this also start to accelerate the way that the customers I work with are able to develop software as well. Okay. And I think right now I'm going to be conservative and say that I think a lot of teams are getting at least a 2x performance from leveraging AI. And, one of the real low-hanging fruits, of course, is to help you debug faster. The average team today spends anywhere from 20 to 40% of their time debugging their embedded systems. And so if you actually do the math on that, that works out to anywhere between 2.5 and 5 months per year per developer. And so if you can get that number down, think about how much extra time you have and how many fewer weekends you have to work every year. So again, look at where your pain points are and ask, where can I use these new tools and AI to try to help me go faster? Now, it's not all about artificial intelligence. I mentioned earlier, I talk a little bit about machine learning. I've been working with machine learning actually far longer than artificial intelligence. Machine learning, I think I started playing with a decade ago. And this is a tool where we can actually deploy inference models on chip to help us, I'll say, write algorithms or execute algorithmic code that maybe we wouldn't have been able to do in the first place. Let me give you an example. Several years ago, I had a product that I was working on for a customer, and it had a gesture. It basically had a gesture sensor on it, okay? And you could swipe your hand, across it. You can move it up and down, and it would cause different features to happen on the particular product. Super cool. Now, back then, machine learning really wasn't a thing at all. And I think I probably spent somewhere between 4 and 6 weeks developing an algorithm that was robust enough based on data that we had collected from the sensor that was on the system that got it working really, really good. I mean, it was one of those things where it's like, okay, this gesture sensor, we're good to go. Everything is perfect. 4 to 6 weeks of development. Was very happy with the way it worked. Okay, a lot of work, but it was a little IR sensor that would reflect light, and all kinds of interesting things could happen with and you'd say, well, 4 or 6 weeks, Jacob, come on. When you think about the variability between different sensors, you have to make sure that the algorithm could catch all kinds of things, people with different hands, different skin colors, all that stuff. So it wasn't a trivial endeavor to go through and actually design the algorithm for this. And what ended up happening was maybe 2 years after I worked on that project, machine learning really kind of came onto the scene. And I was like, oh, this is really interesting. I'm like, I wonder how long it would have taken me to develop this gesture algorithm if I instead had taken my data and trained a model and then converted it to run on the 16-bit microcontroller we were using, and what would have happened, how long would that have taken? And I went back and I took the data that I had that I had collected, and of course with permission from the customer, and I ran the machine learning algorithm all over again. And what I discovered was, or I created the machine learning algorithm, and what I found was that it ended up taking me like a day to a day and a half to come up with a really good, robust algorithm that I could run on chip. Yes, it was machine learning, so like I basically created an inference algorithm that would run on the microcontroller and take the sensor data, and then it would determine whether and what type of gesture was actually present there. And that kind of taught me an interesting lesson in that, it took me 4 to 6 weeks to do this before. And then with machine learning, it took me a day to a day and a half. And so right there, think about the performance improvement of how much time and money could have been saved by leveraging machine learning on chip. And you can certainly say, well, maybe you think you don't have processing power for that. But I kid you not, this was running on a 16-bit microcontroller. And the inference algorithm that was ran, I mean, it was all like lookup tables. There was nothing, ultimately, you really didn't even notice a performance hit on the processor to run machine learning on chip for this particular application. Now, certainly there's all kinds of cool things you can do with, machine learning for like camera and image recognition and all that kind of stuff. And what's really interesting, I think, today is that microcontrollers have kind of stepped up to the plate. And you'll find neural processing units on board. You'll find like Cortex M85 chips that are fairly inexpensive. You'll find all kinds of cool things to help you run inferencing on a resource-constrained microcontroller today. And so if you have some algorithm that you're fighting with, what I would encourage you to do is say, is this actually a good candidate for using machine learning? If you have a lot of sensor data coming in, you need to make decisions. Should you be hand coding all of that, or does it make more sense to train a model that can go and make the decision for you based on the data that's presented to it? All right. So again, super exciting times. I think I've worked with medical device companies that are working on I'll say safety critical devices. They're like ventilators and things like that, where they're using machine learning on chip to detect certain types of events, problems, and other types of things that you maybe wouldn't have even been able to do before you could run machine learning on a chip or on devices. So really exciting times. And so, trying to bring this back, what does this have to do with, step 6 of modernizing your embedded systems? Well, I think you have to adopt AI and machine learning. And I'm not saying you have to, but what I'm saying is you're going to be left behind if you don't look at how you can apply AI and machine learning to your applications today. If I were to actually go back, like if I was just starting this entire series, I probably would say that, one of the first, AI and machine learning adoption wouldn't be step 6. It would actually be, first one would be metric scoreboard, followed by AI and machine learning. And then after that, it would say, our software architecture, our build system, and so on and so forth. Okay. And that's why I kind of say the order really doesn't matter. It just depends on where you are as a team as to which of these steps will actually help benefit you the most. And so don't feel like you have to go through these in any specific order. And certainly there's a lot of details that go into each of these. But again, super exciting times, I think. You should be looking at AI and machine learning. If you are a developer and you're going, Jacob, this stuff sounds cool, but I don't know where to go, or you're a team and saying, how do we apply this stuff? Reach out to me. You can contact me at jacob@beningo.com. At the end of April, I'm actually going to be running an online workshop all about AI for embedded developers. Super low cost. It's going to be a lot of fun. We're going to be, talking about how you develop skills, how you develop agents, how you create MCP servers, how do you go about using RAG, how do we apply different techniques to developing an embedded system. Okay. So I think that's going to be kind of fun. If that's something you're interested in, because you listen to my Embedded Frontier podcast, you can actually register on Beningo.com by going to training, individual courses, finding the AI course. Then if you put the code in Frontier, FRONTIER, you'll get a $100 discount on it. So it's already very inexpensive. It's like $295, so you can get it for $195. And this isn't me trying to sell anything. This is me trying to say these techniques are really important. And if you can't figure it out yourself, let me help guide you. So, because I don't want you to fall behind. There's so much going on. We've seen the scares, like just on Friday, Block announced that they were going to lay off like a third or half of their workforce. And they claimed it was because of AI, right? And yes, they're a fintech company, but ultimately, embedded systems tends to be anywhere from 2 to 5 years behind everybody else. And so you can be assured that there are people right now who are looking to try to figure out, how do I apply AI to developing embedded systems? And it's not that they might be looking at it. There are people out there today. I talk with vendors all the time, and I know at least half a dozen, if not more, who are currently developing products that, are using AI and can help accelerate the way we're developing systems. I'm trying to come up with techniques for developers to help you move faster using these types of techniques. So, but ultimately, you have to do what makes the most sense for you and your team. And maybe based on the types of systems you're working on, maybe it doesn't make sense. It may be that in safety critical applications today, that trying to leverage these techniques is too high of a risk. Okay. But if you're working on other, IoT based devices, or where you just need kind of general robustness, I mean, there's lots of different industries out there. I still think that even if you're in safety critical, you should at least be exploring AI and saying, how could this potentially be used? What techniques could be applied? Because ultimately, it's going to make sure that you stay at the frontier of developing embedded systems. And that is going to help ensure that during this fourth industrial revolution, that you actually continue to maintain the skill sets that allow you to provide value to your employer, to your team, and so on and so forth. So let's not end this on a scary note, because ultimately I think what AI is going to allow us to do, it's not going to get rid of embedded developers. I see this as a major productivity tool for us. most of us are already underwater with the amount of work we have to do on a daily basis. And so I think this actually provides us with that multiplication factor so that we can actually get done what needs to be done and so get to start enjoying the way that we develop embedded systems again, right? Instead of doing the same thing over and over again, we can let AI do a little bit of it for us so we can focus on the interesting problem space that we really want to be working on, okay? So don't take anything away that's scary. Just get really excited because where embedded systems is going to be going in the next several years is really super exciting, okay? And if you want to see some of where that is that we're going, I'm actually going to be giving a keynote speech at the Embedded Online Conference in May, all about firmware 2035, which is going to I'm going to try to look into the future and let everyone see what it might look like to develop embedded systems almost a decade from now. Okay, it's I'm losing my hair because of it. If you're watching the video, that's why my hairline is receding. That's a tough cookie to crack, I think, but I think it's going to be a lot of fun. And there's also a lot of other great speakers and colleagues and workshops that are going to be at the conference. So I think we're still in the early bird phase. So, try to register as soon as you can. It's going to be extremely fun. And certainly always, provide us feedback on this podcast and what you might want to see at the Embedded Online Conference or other things that you're having related to issues with AI or embedded systems in general. Where software meets hardware, this is where I think all the fun really is. And so, let me know how things are going for you. And I'll look forward to talking with you all again in the next episode, where we're going to actually conclude this series by talking about how to develop a metrics scoreboard. I know it's the last step in the modernization process. It should be the first, but I think it's the one that's probably the most boring to most developers, right? We don't like metrics. We don't want to track things, but I'm going to share with you why it's so important, how we can actually identify the metrics that are important, and try to give you a feel for how you can actually develop dashboards to give you feedback without having to put in a whole lot of time and effort. And, spoiler alert, AI is fantastic at doing those types of things. So, all right. With that in mind, I wish you all happy coding, and I look forward to talking with you soon.